Okay, now we'll use an example to help understanding the regression estimation. We are now suppose that we are interested in estimating the total number of dead trees in an area. The population consists of 100 plots, and suppose that we select uh, 25 sample out of the 100 plots by simple random sampling. Okay. And from the sample, we use field determination. So we visit there and actually count the number of dead trees for that plot. Okay. So then from the sample, we observe yi. On the other hand, in the population, we still have information. The information is the photo determination. Okay, so we take 100 pictures for each one from each plot, and use the photo and do some guess, right? Some kind of a measurement using the pictures, and compute the count. And so let's call this xi. And because we have all the pictures available for each plot in the population, we can actually compute the population mean of x, which is 11.3. So here's the actual plot. So we have a 25 element. Okay, so it's 25. So we have 25 dots here, and the blue one is the regression line. So y hat is b0 hat plus b1 hat x. Okay, and this x bar, the red one, is the population mean x bar u, which is 11.3. So you can see that this number, okay, should be the y bar regression, right? Okay, and the table here. So we actually use the sample 25 samples to analyze it, say using SAS or whatever. We obtain this estimate. So this is B0 hat, this is B1 hat, right? And this is the standard error. So standard error of a B1 hat estimate. So this is a T, is a B hat, B1 hat divided by standard error of the B1 hat. Okay. So basically this is 0.6113 divided by 0.1601, something like that. And this is the p-value corresponding to the distribution. And now the f value. So this is a sum of square. This is sum of square regression, and this is a sum of square error, right? And this is sum of square total. And this is n minus 1. This is n minus 2. Okay, so this one is MSE is the SSE divided by n minus 2, and this is the F. F is the SSR divided by 1 divided by MSE. Okay, so this guy divided by this, so that means 84.999 divided by 5.1789, and this value is actually, so the connection is that this value is a 3.83 square. Okay, so for the main estimation, the regression estimator is the predicted value of y at x equal x bar. So we use x bar, which is 11.3, to the regression coefficient to obtain the regression estimator. Variance estimator, for variance estimation, we use this formula, and SE is SSE divided by n minus 1. So that is, this one is, SSE is what? 133, okay, 16 divided by n minus 1 is 24. Okay, that gives us 5.548. So that is the standard error. And total estimation, so total is n times the y by u. So total estimator is n times y bar. Okay, the y bar is the sample mean of the so this is y bar is a estimator of y by u. And furthermore, standard error of t hat is n times standard error of y bar. Okay, so that's basically what's going on here. So you just multiply 100 times to the 11.99. So that means the estimator, regression estimator of the total is 1199, and so that is an estimate. And the standard error is n times of the standard error of the regression, which is a 0.4080. So that we obtain this value. So using this point estimation and variance estimation, we can obtain confidence interval too, right? We can just use 1.93. So point estimator plus minus 1.96 times the standard error, you will have the confidence 95% confidence interval. Okay, so that's all for regression estimation.